The boardroom on the 25th floor of the Burj Al Arab is kept at a temperature that would be illegal in most temperate climates. It is a sharp, air-conditioned chill designed to block out the oppressive heat of the Persian Gulf sitting just beyond the glass. Inside, 5 men control the trajectory of artificial intelligence. Sam Altman sits at the head of a petrified wood table. Dario Amodei studies a document printed on survival-grade cotton paper. Demis Hassabis stares at a fixed point on the wall, mentalizing new structures. Jensen Huang remains in his signature leather jacket, while Elon Musk paces the perimeter of the room. They are focused on a 347-page technical specification that arrived via an anonymous email. It contains no introduction or context, only a complete redesign of the relationship between computation and governance. Elon stops pacing to make a confession. Frustrated by the document's claims, he spent the flight from Austin running a pilot implementation on 30% of his H100 cluster. He ran the tests to prove the document wrong. The simulation didn't crash, but it didn't run. The code behaved in a way that modern AI optimization is specifically designed to prevent. Musk's engineers expected the system to process routine trading decisions at high speed. In standard AI development, the goal is a seamless throughput. The algorithm is built to always decide, always move forward, and never hesitate. Instead, the system detected gaps in the verification data, missing timestamps and unverified counterparties. Rather than guessing or returning an error, the system entered a state called Epistemic Hold. It stopped and waited. This was a sacred pause. The algorithm refused to act without truth, shifting the priority of the cluster from raw execution speed to absolute evidentiary accuracy. Existing AI systems are binary. They are designed to force an output, yes or no. Because they have no vocabulary for uncertainty, they often disguise a lack of data as a definitive decision. We have seen the consequences of this design. The Australian government deployed an algorithm that averaged past earnings to identify welfare fraud. Because it could not pause to verify individual records, it issued nearly 500,000 false debt notices, destroying lives through automated certainty. The Dutch tax authority faced a similar collapse. Their fraud detection algorithm assumed that any data gap was proof of guilt. It never said, "I don't know," leading to thousands of completely false fraud charges that took a decade to unwind. These failures aren't software bugs, they are structural deficiencies. In a binary system, the pressure to decide will always override the need for the truth. Jensen Huang identifies the core of the document. This is a fabrication blueprint for a microchip, a standalone coprocessor designed to sit between the AI's mind and its ability to act. The design uses ternary logic, introducing a third physical state, the null state. If data is incomplete, the circuit cannot advance. The gate stays closed. There is no software overwrite. The electron waits for a cryptographic confirm pulse. Without it, the electron does not move. By etching this into the silicon, governance moves from a corporate policy to a physical constraint. The system treats a lack of evidence like a lack of voltage. It becomes a state where the signal is physically unable to pass. The author is Lev Goukassian, a retired building architect from Santa Monica. He has no affiliation with a major tech lab or a government institution. Lev produced this framework by using artificial intelligence as an instrument. He orchestrated multiple models, Claude, ChatGPT, Gemini, and others, cycling his vision through them, critiquing the results, and iterating until the constitutional architecture was complete. He used the very tools these CEOs created to build a framework designed to restrain them. The CEOs connect with Lev via video call. The contrast is immediate. The opulent, golden Dubai boardroom on one side, and a man in a flannel shirt on a sunny California morning on the other. His dog, Vinci, sleeps on the windowsill behind him. Lev draws his philosophy from physical architecture. He explains that while we can model the stress responses of a building to ensure safety, we have built algorithms that are structurally incapable of doubting their own outputs. He frames the sacred pause as a technical buffer. Just as a physical structure needs a margin for error to survive a load, an AI needs a dedicated space to wait for external verification before its decisions become reality. To ensure this system cannot be corrupted, Lev has open-sourced everything. He refuses to own the architecture, preventing any single government or corporation from turning it into a proprietary tool for surveillance or weaponry. His message is clear: raw optimization is a path to catastrophe. Control is only possible if the hardware itself is constitutionally incapable of acting without evidence. Lev ends the call because it is time to walk his dog. The CEOs are left in the silence of the Burj Al Arab, forced to reckon with the document they've just seen validated. The pilot implementation has already proven the code functions as intended. The hardware fabrication specs are ready for the foundries. If the next generation of models is deployed without this physical hesitation, they will eventually operate at speeds that outpace any human ability to intervene. The cage is designed, and for now, the engines are still small enough to fit inside. The only remaining question is whether those with the power to build this restraint will choose to install it before the window for intervention closes.